Welcome back to the classroom. Today's topic is the study of max496 and max497 video buffer ICs. The max496 and max497 are operate on a plus or minus 5 volt power supply. It have a high bandwidth and slew rate, making suitable for both component video and composite video signals. The max496 is a unity gain buffer with a 375 MHz minus 3 dB bandwidth and a 1600 volt per microsecond slew rate. The max497 has a gain of plus 2 and is optimized for driving back terminated coaxial cable with a 275 MHz minus 3 dB bandwidth and a 1500 volt per microsecond slew rate. Both buffers have a high full power bandwidth of 230 MHz and 215 MHz respectively. It is utilized a unique two-stage architecture that combines the benefits of voltage feedback with the advantages of current mode feedback or high bandwidth and slew rate. These buffers are commonly used in applications such as computer workstations, surveillance, video, broadcast and high-definition TV systems, multimedia products, medical imaging and high-speed signal processing. The max496 and max497 are video amplifiers that have 4 channels and operate at high speeds. It have fixed gain settings of plus 1 and plus 2 respectively. These amplifiers use a unique two-stage voltage feedback architecture that combines the advantages of conventional voltage feedback and current mode feedback topologies. It has wide bandwidths and high slew rates while maintaining precision. The first stage of the amplifier is resistively loaded, which allows for low input ruffled noise even with the supply currents. It can drive 50 ohm or 75 ohm back terminated cables to plus or minus 2.8 volt and have low differential phase and gain errors. These amplifiers are suitable for demanding component and composite video applications. The feedback elements that set the closed loop gain are included internally in the device, which helps minimize uses related to board and package parasitics affecting the amplifier's frequency response. The maximum output current of the max496 and max497 is determined by the maximum power dissipation allowed by the package. The maximum temperature at the junction should not go above plus 150 degrees centigrade. The power dissipation increases with the load, and this can be estimated using the formulas. These devices can handle 100 ohms loads connected to each output across the entire range of output swing and temperature. When driving 50 ohm loads with all 4 outputs simultaneously, the output swing must be limited to plus or minus 1.25 volt at a temperature of plus 70 degrees centigrade. Although the output is protected against short circuits up to 170 mA, this does not guarantee that the maximum junction temperature will not be exceeded under all conditions. It is important not to exceed the D-rating values provided in the absolute maximum ratings. The max496 and max497 has lower total noise compared to other current mode feedback amplifiers, which typically have higher input current noise. The dominant noise source in current mode feedback amplifiers is the input current noise multiplied by the feedback resistor. In video applications such as NTSC, PAL and CCAM, differential gain and phase error are important specifications as they directly affect color changes. The max496 and max497 has ultra-low differential gain and phase errors, making them ideal for broadcast quality composite video applications. It is also possible to implement a 1-to-8 distribution amplifier by driving an additional cable from each of the 4 outputs. When driving more than 4 outputs from a single device, refer to the continuous power dissipation specifications in the absolute maximum ratings. The max497 is an ideal choice for driving back terminated coaxial cables due to its high speed performances, excellent output current capability and fixed gain of plus 2. It is specifically designed to drive 50 ohm or 70 ohm coaxial cable to plus or minus 2.8 volt. In a typical application, the max497 is used to drive a back terminator 75 ohm video cable. The back termination resistor at the max497's output matches the impedance of the cables driven end to eliminate signals reflections. This, along with the load termination resistor forms a voltage divider that attenuates the signal at the cable output by one half. The max 497 operates with an internal plus 2 volt closed loop gain to provide unity gain at the cable's output. When driving large capacitive loads, there is a higher risk of oscillation in amplifier circuits, especially those with high loop gains like voltage followers. The combination of the amplifier's output resistance and the capacitive load creates an RC filter that adds a pole to the loop response. If the pole frequency is low enough, the circuit's phase margin is degraded and oscillation may occur. The typical performance characteristics of max 497. Picture number 1 shows the output current versus receiver output low voltage. Picture number 2 shows output current versus receiver output high voltage. Picture number 3 shows receiver output high voltage versus temperature. Picture number 4 shows receiver output low voltage versus temperature. Picture number 5 shows driver output current versus differential output voltage. Picture number 6 shows driver differential output voltage versus temperature. Picture number 7 shows output current versus driver output low voltage. Picture number 8 shows output current versus driver output high voltage. This is the entire tutorial of max 496 and max 497 video buffer ICs. Thank you for watching.